INS is a strategic partner with Solona Technologies. Solona is one of the leading private cellular providers in North America, really focused on industrial applications and enterprise solutions. INS has been working with them for a long time, and one of their strategic account managers approached us regarding a customer they were working with named Conca. I had never heard of the name Conca before, and so of course you go online and find out who they are, and you see that they are a manufacturer of marble, very large, nice rocks. So you can imagine if you go into a really nice hotel, a really nice shower that you built or a bathroom that you built, the high-end, high-dollar marble is what they do. So they are very big into technology. They have always been very automated plants. Very odd. When you go to their plant, there's maybe 10 people that are working. So inside this, when they're making this large rock, this rock is very, very heavy, very heavy. And so they use automated guided vehicles for this, for the movement of this material. So as they're polishing this rock or cutting this rock or moving this rock or stacking this rock, it's pretty dangerous, and it's also very automated. So they were having considerable issues with their automated guided vehicles, AGVs, because they were using Wi-Fi connectivity. And so this customer, being one of the forethinkers, that they were doing private wireless before private wireless was cool. Very innovative IT team, a very supportive CEO, and they wanted to find a way that these AGVs wouldn't lose connectivity. And private cellular is really perfect for that. So when you do a private cellular network, one of the first things that most folks want to do is a proof of technology or a proof of concept. It's a little bit of a enigma, right? That hey, I have my own cellular radio. Isn't that the $1 million thing that I see on the freeway with millions of connections to them, with cars going by at 70 miles an hour? And so private cellular is a newer technology to a lot of folks. It's a rapid growing space. So one of the first things we talk about with Conca is the proof of technology and the proof of concept. And they're all excited about that. So led by Walter Rumbelow, who's one of our first and foremost systems engineers, an amazing system engineer, led our private cellular initiatives on several applications.
Yeah, here at INS, we leverage a project execution model called the 4Ds. Discover, design, develop, and deploy. Those 4Ds are typically executed sequentially. The most important of those being discover. That sets up all of the information required to fully design, develop, and deploy a system for our customers. The success for any of the subsequent phases is based on that discover phase. So we put a high emphasis on discover. Communicating with the customer, what are your needs? What are your operational constraints? Why are you implementing this system? And then we do a very detailed discovery, going on site, looking at their existing infrastructure, looking at the technology that's proposed for the solution, making sure that it meets the needs of the customer. And that sets us up for the design phase.
So we purchase the radios, we stage the radios, we test the radios in the INS lab environment. And as we're configuring this, the INS wireless team will come up with a full array of tests. The system engineering part of it is where I think INS really comes into play, because we know advanced networking technologies. It's really unique in cellular that most people that design cellular networks from day one kind of always designed it from the edge to something out in the internet. That's how it was always built, right? It was never meant to be a layer 2 network, okay? And so that's kind of the beauty of Wi-Fi versus cellular, is everything in Wi-Fi is a layer 2 network. So when you need machine-to-machine code or machine to the software package on a flat network, you have to learn you have to put systems in place and technology in place for it to behave as a layer 2 network. That's really where INS once again really shines, because we have advanced networking.
Yeah, we deployed one-to-one NAT. We leveraged the technologies in the industrial cellular radios that were deployed on the AGVs to allow them to connect to the PLCs that were located on the AGVs directly from their management software that was running on a laptop. And in order to do that, we had to set up one-to-one NAT. That is a built-in feature for the Cradle Point radios that were deployed. That allowed them direct access to log into the PLC, make modifications, do troubleshooting on any of the multiple of AGVs that they had deployed in the site. To go further on what Joel said, they deployed redundant cores at this particular facility. They had 3 cores that were geographically dispersed around the site that had separate power supplies, so that if one of the locations lost power or network connectivity, one of the other cores would take over. This was one of the main features that Dell Conca requested. So we fully vetted and tested that.
So for the Dell Conca application, not only did INS do the engineering and the design, the testing, we also did the full installation of the solution, including the enclosures, the core, the radios, and the cellular devices on the AGVs themselves. We then go through a startup testing procedure to make sure indeed that every system is working as it should. We document it. And of course, we have the customer fully witnesses it. And depending on the customer, but usually we stay around for a day or 2 after the system starts to make sure there's no issues on the network once the plant's in full production.